To test for carbonate ions, first place a small sample of each of your unknown solutions into boiling tubes. Then, add several drops of hydrochloric acid. If effervescence is observed, then carbonate ions are present in the solution. This can be seen in the boiling tube for sample 1. Effervescence is observed due to the reaction of a carbonate ion with two H+ ions to give carbon dioxide gas and water. This can be seen in the ionic equation at the bottom of the screen. In this example we use sodium carbonate, which is aqueous. However, most carbonates are solid. If the carbonate you are testing is solid, remember to change the state symbol for the carbonate containing compound and the CO3 2- ion in the ionic equation from Aq to S. To test for sulphate ions, first place a small sample of each of the unknown solutions into boiling tubes. Then, add several drops of hydrochloric acid. As from the first chemical test for carbonates, this identifies any carbonate-containing solutions, as seen in sample 1, which we will not test further in this experiment. After adding the acid, we add several drops of barium chloride solution to each of the boiling tubes. The presence of a white precipitate indicates the presence of sulphate ions. This can be seen in the boiling tube for sample 5. A white precipitate is observed due to the reaction of a sulphate ion from the unknown solution with a Ba2+ ion from the barium chloride, forming barium sulfate, an insoluble white precipitate. The ionic equation for this reaction is shown at the bottom of the screen. The final chemical test is to identify the halide ions present in the unknown solutions. To start, a small sample of each of the unknown solutions have again been placed into boiling tubes. Then, to test for the presence of halide ions, first add several drops of nitric acid. As from the first chemical test, this identifies any carbonate-containing solutions, which we will not test further in this experiment. Secondly, we add several drops of silver nitrate solution to each of the boiling tubes. Precipitates of different colours form depending on the halide ion present in the unknown solution. The white precipitate of silver chloride seen in sample 2 indicates the presence of chloride ions. The cream precipitate of silver bromide seen in sample 3 indicates the presence of bromide ions. The yellow precipitate of silver iodide seen in sample 4 indicates the presence of iodide ions. The precipitate forms due to the reaction of the aqueous halide ion from the unknown solution with an aqueous Ag+ ion from the silver nitrate solution, forming the silver halide. This is an insoluble precipitate with a different colour depending on the halide ion used. The ionic equation for this reaction is shown at the bottom of the screen.